Welcome back. We're back in Scilab, and in this uh, short tutorial, we're going to talk a little bit about digital modeling. Now, I did give a quick overview of doing some basic math in Scilab itself, and we are going to talk at some point about how to get information from here to there, but most of us are probably not that interested in doing a lot of math. What we want to do is model systems, and you don't need to know or be an expert on math to use XCos to model systems. So let's go back here to do I have it open? No, I don't. Let's go back and bring XCos up again, and here it is, our original one that we did. I'm going to, and I called this what I call this example. Okay, a simple example of that. So let's build a little digital circuit and test it and see what it does, see what kind of outputs we get. So I'm going to come over here. I'm going to go new. I'm going to take this and I'm just going to drop it into the main one. So now another little feature here. I dropped it right on top of that other one. We've got Untitled XCos in this tab down here, and over here is that other diagram. So I can actually close that now. I don't want it open, and now our one diagram is there. If you close the diagram, by the way, the last diagram, XCos will close, just to be warned about that. And what do we got over here? Oh, yeah, that's that. So we got to pull this out just a little bit so we can see our little buckets of stuff. Okay. Now there's some little tricks that we have to do here with this, and we're going to use a little bit different type of scope on this because we want to look at multiple signals, and I don't like to see them all overlapped. So we're going to use this CM scope, and I'm going to just go ahead and pull that out here. And again, oops, I'll pull this over here somewhere, and I'll zoom this up. We don't need a lot of room. I'll pull this over here. So we've got our CM scope, and we're still going to need a clock. And I've got a clock right here. This is in my recent. So if you want to know where those are, the clock is in sources, and we're using this clock C. And the scope, the CM scope, is in sinks. So let's go back to sources and get our clock. And we'll put that right over here. And we can hook up this red arrow. You notice, I don't know if I explained this before, but when you hover over the arrow, you get a little green box. If you click and drag, it pulls out a wire, and you hover over and you get another green box and simply release, and they're connected. If you want to remove a connection, you got to be careful. Click on it so it's highlighted, then just touch the delete key and you'll delete it. So another little caveat to watch out for: if you have something like this selected and you come over here and select a wire, it will select both. If you then delete, you'll delete both of them. I know most systems don't automatically add selections in. It only does this with wires, it seems. And maybe that's a little bug in the system, but be sure nothing is selected before you select a wire in order to delete it, or you'll delete the other thing as well. So what do we want to do here? Let's go up here to the one that says integer, and in integer you will see there's a D flip-flop. What am I looking for? I'm looking for and, this one right here. Now it says and in it. It's a logical op block. I'm going to show you how this works right now. Let's pull an and into here, a logical block into here, and you'll see across the top it says operator codes. 0 is and, 1 is or, 2 is NAND, 3 is NOR, 4 is XOR, and 5 is NOT. So that's right here, operator code. You can set this to one of those numbers and you'll get that kind. And then you can tell it how many inputs you want. There's something about that I'll show you in a minute. Sometimes there's a couple ways you can tell it the number of inputs, and one way is better than the other, and it comes down to those things we talked about earlier, vectors. So right now it's just set to 2 inputs, and let's make this an OR gate. So an OR gate is a 1. So we'll make an OR gate, and now it says OR. That's really nice. Now I'm going to just copy, Control C, Control V, and make 2 OR gates. Do I want 2 OR gates? Now let's just stick with the one OR gate for the moment. We're going to do a little demo here. So our OR gate, we're going to ultimately put in the second one of this. And also, if you want to make things look neater, you can expand these things out, and you'll get more width on the between the inputs, which can make the diagram a little neater. I usually try to set the diagrams up rather nicely. So now what we need is another source, and the source we want is this gen square f. And you'll notice, and we're going to get two of those, so I'm just going to code Control C, Control V. You'll notice that they need a clock. Okay? And so we're going to drag two clocks into here, one for each one of these, and go ahead and hook those up. The clock is, of course, going to tell us the frequency of this, how we do this, and it does it right here. I'm going to double click on the clock. Oh, come on. There it is. There's a period and an initialization time. So right now the period's 0.1, the 10th of a second. That's fine. We'll leave it at 0.1 for the moment. And the initialization time we're going to set to 0. And this one, we're going to have it twice that frequency. Or the period, to have it twice that frequency, it would have it, well, we'll make it half that frequency. Or in other words, double the period. And we'll set this to 0. All right. Now, if we plug this into here and this into here, now that doesn't look very diagrammatic. So what we can do is hit Control A and then touch the O key, and it'll make things nice and neat. Then what we can do is I want to take this signal. I'm looking at the OR of the two. I actually want to look at the output of this, but I want to look at both of these signals on this scope. So how can we do that? Well, let's double click on this. And you'll notice here for input ports, it says 1 space 1. That's how the others should really be. They should be in vector form. We're just going to add another port by putting a 1 there. But now there's a couple other things we have to do. You notice the Y min vector, this is the minimum value, has each of the scopes have different values. Well, I want the min value to be 0 in all three cases, okay? And I want the maximum for all three to be 1, because that's how tall our square wave is. Actually, it might be this might have to be -1. Let's try that. Now we've got 3 ports, and if we click this, you'll notice, oops, refresh periods. Yeah, we got to add another refresh period. So these vectors all have to be the same size. There's 3 here, so it's going to be 3 input ports, 3 minimum values, 3 maximum values, and 3 refresh periods. And now we get 3 ports. And I'm actually going to delete this one. You notice it, yeah, it had that selected. Shoot. If you accidentally do that, hit escape, and then we'll delete this. I'm going to put this one on the bottom. Then I'm going to grab this line, and I'm going to drag off of it, and I'm going to hook it to the top one. And I know it gets all wonky when you do that. And I'm going to grab this one here and drag off of it, hook it to there. And then we'll go Control A and hit O, and it kind of straightens it out. We can lay this out better and it'll straighten it out, but this will work. And then I'll try to neaten this up a little bit. So if we run this now, hopefully, so that's a lot of square waves. So this is where we got to do something with our scope. All right, so the refresh period right now is 30. So let's go up here to the simulation setup, and so this is also set to 30. Let's set this, period is 0.1, so it's going to be 10 hertz roughly. So we probably want to set this refresh period to something like 10, 10, 10. And then the simulation setup, we're going to want, and I'll explain this simulation setup later. Let's set that to 10 right now and see if that does it. I sometimes run into trouble doing this. This should have expanded out. Expanded a little bit. Let's do this. That's kind of odd. We've got our two different square waves. This is supposed to be a square wave. Oh, I know why. I went the wrong way. Let's set this up to about 100, 100, and 100. Let's go up to simulation setup. This is the number of, this is the length of time that the simulation is going to run for. Okay, let's change this period. Come on. Let's change this to 2 and change this to 4. And let's shoot this back down to 30, 30, 30. Leave it at its default. Simulation setup. I think I was adjusting the wrong thing. Let's set this to 30. So that's 30 seconds of time it's running for. So that's a little bit better there. We've got a square wave in. And why are we getting all this? That shouldn't be that fast. What did I do? Oh, how'd that get to be 0.2? This is supposed to be 4. Amplitude 2. Did I change this by mistake? Yeah. Let's set that amplitude to 1. Okay, I should have changed the clock to 4. Okay. Let's try that. See if this looks better. Okay. That's much better. Let's expand this out. So we're ORing these two signals together. So when this is on and this one is on, this one is on. So it's on here, it's on here, it's on here, this one's on. It's only off when both of them are off. So this is the OR function. So we've just created a new waveform with this little notch in it just by ORing those two together. Let's see what would happen if we change this from OR to AND. So AND is 0. Let's make it an and run it. So now we have just little short high spots only where the two signals are both on. So here it's on. So we can see the logic. This is high, this is high, this is high. So this is the AND output. This is high, this is high, this is high. When they're low, either both low or one is low, it's low. So it's low during this entire period. What if we were to do a different kind of 2 input? Let's do NAND, which is 2. It should be similar to AND except inverted. And it is. So now when they're both high, it's low, and any other condition, they're high. So there is a simple signal processing thing. Now if you want to do this a little more neatly, this is a little bit weird to try to move stuff around. There. That helped a lot. This line here really could be up here. And we could have changed that around, but I wanted those two on top, so that's not too bad. Let's move this up to here. Control A O. That looks a little bit nicer. So you can move things around and shuffle them around and get the pieces looking nice. So let me see what time we got here. We're 15 minutes in, so we can do. You can obviously combine circuits together, make different logical operations. Do this. So one last thing that I want to do is show how I could turn make a circuit, and I think we got time to do that, and make it into its own block, a separate block. So I'm going to start by getting rid of all of this source stuff on here, and all of this. You know, I never saved this file. Control Z. I want to save this file. Control S. And we're going to call it and example. And come up here. Sometimes the flags don't open right away. That's save. Oh, I want new. Okay. Let's create a new diagram. We'll drop it in here. Oops. We'll drop it in the whole thing. There we go. So there's a couple ways you can go about that down here under user-defined functions, and we're going to use this a lot. There's this thing called a super F block. If you drop this on here and double-click it, you get a new diagram. And it's got these input ports. And if you come over here to, is it signal routing? Yeah. What did it do? Oh, I didn't dock it. So let's just go ahead and dock this one up here so we can see it. Now let me zoom it. Now let me zoom this one. Oh, not that. Let me put this up here and zoom in. So this is that special function block, and we've got these inputs and outputs, and those are here. And so these are those clock from and clock to signals. So if we have this is a from, and this is go to, and we can make it look a little bit more like that default one there, or you can just copy it. We can double click it, and port number 3, and this is port number 2. What's it saying here? It doesn't like. Wrong port number 2, but got 3. Okay, and that can be 1, and this one can be 2. Come on. Make that a little smaller. We'll just do one output. And what we'll do is we'll make a 3 input. Let's go back to our integer. Let's get a logic op. And another logic op, and we can make a 3 input AND gate simply by doing this. Now you don't need to do this because you can make an AND gate with as many inputs as you want, but to show you how a diagram works, A, O. Now that right there is a 3 input AND gate. Not sure. why it didn't update the inputs. And why is it bothered by this? So let's, well, we can't run it because it doesn't have any sources and sinks, but maybe that'll compile it or something. Yeah, now this one's got a problem. Block is ignored because undefined inputs. Okay, so now we can do the same kind of thing. We can go back to this one. We can grab this, Control C, go back to this one, Control V. I'm not sure why that's showing only, this is only showing one input when I put additional inputs on it. Let's see what happens when we might need to compile it or something. Huh. Well, we do get some strange behavior once in a while, some unexpected behavior from time to time. Well, there is another way of doing this. So I'm going to close that. And I'm going to delete this block. So another way of making that, and I think this will come out with the proper number of gates on it, is if we just create a circuit. We'll take our two AND gates, chain them together. These are our three inputs. This is our one output. We go back here to, what did I say it was? Was it signal routing? Yeah. And we go from hook this up. Oops. Hook that up there. Hook that up there. And then go to hook that up there. If we then select these and go here, oh, come on. There it is. Selection to super block. Okay. Now we can delete these. And that's probably the easier way to do it, to get that super block. And you notice we now have the three inputs that we wanted as actual inputs on this. So then we could take and copy this and so forth and hook it all up. And this would be a 3-input AND gate right here. And you notice it's got them all properly numbered and everything. And what is this block anyway? Input port block parameters. Input port. Did I use the wrong kind of input port before? Go to from port and subsys. Oh, that's what I did. Okay. When I hooked that other one up, I used the wrong kind of input port. So let's try this again. Real quick. Go to user define. Let's grab that super F block. Open it up. And let's go up here to, let's drop this in here. Grab this. Let's go up here to port and subsystem. So I usually port and subsystems. Yeah, in F and out F is what we want. So we've got 1, there's 2, there's 3. Let's double click it. Let's expand this so you can see, because everything's miniature. Let's make this 2. Let's make this 3. And then let's go to integer, grab our 2 logic gates, and hook them up here, inputs to here, 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 and here. Control S to save that. And 3 in and we'll call it. Let's go back to this one, and there's our there it is. there's our other 3-input AND gate that we made that way. So there's a couple different ways to do it. You can make circuits like this. One last thing is you can put labels next to things by double-clicking and then double-clicking the text and typing in some text that you want on the screen. It's very simple. That's how you put text on the screen. I don't think there's any way to name these. If there is, I will set context. Oh, that's for working with Scilab. Setup. Set parameters. That's the that's the same as going to simulation setup. It's the same thing. Show parent diagram, zoom diagram, background. Yeah, I don't think there's any way to like give it a name that's attached to it, but it allows you to create sub-circuits and build up from there. So we're right around 26 minutes, so I'm going to end it here. In the next video, we'll start modeling with some control systems and put together a very basic, simple control system. And so thanks for watching. I hope you liked the video. If you liked it, hit that like button. If you really liked it, hit that subscribe button. And I'll see you in the next video. Thanks for watching.